Okay, so we're going to look at an integration by parts problem, and we want to look at how to integrate ex sin x dot dx. Okay, so not an easy problem. You're going to have to use integration by parts actually twice. Okay, so what you can do is, okay, if you're going to use the Lie way, I say Lie, could be other ways, Lie, okay, log, inverse, algebra, trig, exponential, so whichever one comes first, okay, you call that u. Okay, so whichever one you have, the one at the top is u, okay, because if you remember integration by parts, it's uv minus integral of v dot du. Okay, that's the integration by parts formula. So what I'm going to do is, for this problem, okay, I'm going to let u equal, oops, sin x, I was about to write ex, okay, sin x because trig is above the exponential, okay, that means du equals cos x dot dx, okay, my v will be ex, and obviously dv is ex, okay, so I'm going to sub it into this formula. I'm actually going to write ex first, okay, so I'm going to go ex sin x, okay, actually uv, but I've just switched it around, okay, minus the integral of v du, okay, ex cos x dot dx, okay. Now you have to use integration by parts again for this problem. Okay, so I'm going to use u and v again. You shouldn't really, but I'm just lazy. Okay, so I'm going to let u equal cos x. That means du, okay, equals minus sin x dot dx, and dv equals ex again, and v equals ex. Okay, so just move my page here. So I'm just going to concentrate on this part here. Okay, I'm going to leave this part out for now. Okay, so I'm going to drag it down here. So I'm just integrating this ex cos x. So uv again, okay, because that's our formula. Okay, so uv, okay, so I'm going to write ex first, cos x minus the integral. Now you have to be careful here, minus the integral of v du. Du is minus, so if you take that minus out, factorize it, minus and minus gives you a plus. Okay, dot dx. Now I'm going to sub this value back in for this value. There's a negative, so I'm going to have to times this whole value by negative. Okay, I'm going to take that step. So I'm going to times this and this by negative. So what we're going to get, I'm going to rewrite this. Okay, let's move my page up here. I'm going to write ex sin x, okay, because that's what we had, ex sin x, okay, minus this whole part, so minus ex cos x, okay, minus, because a negative times a positive is a negative, minus the integral of ex sin x dot dx. Okay, now what you in this situation, since you're left with the integral of ex sin x, okay, this is not our final answer yet because we have an integral here. See how in the question, okay, let's go back to the question. The question is actually ex. You want to integrate ex sin x dot dx. So if ex sin x dot dx, okay, so far equals this, ex sin x minus x. Yep. So equals this. How am I going to get rid of? How am I going to get rid of this ex sin x here? Okay. So how am I going to get rid of that? Okay. Well, what we do, okay, if you think about adding, so if this is a negative here, if I add an ex sin x dot dx, this will disappear. Okay, so I'm going to add an integral ex sin x dot dx. Okay, that means if so far it equals that, okay, so far it equals that, that means if I add an ex sin x to this, okay, I'm going to be left with this. I'm going to be left with 2 ex sin x because I added another ex sin x. Okay, that equals so far ex cos x. I'll just read it cos x. Don't know why. Ex sin x minus ex cos x. Okay, now how to get rid of this 2? We'll divide by 2. Divide by 2. So the integral of ex sin x dot dx equals ex sin x minus ex cos x divided by 2. Obviously, add a plus c. Okay, I'm just going to add that in the end. Okay, so that'll be your final answer.